Okay, welcome to D period Algebra 2. It's Wednesday, May 5th. All right. After today's class, we've only got, four more classes together, 2 next week and 2 the following week. So we're wrapping things up. Let's see here. I think I got, I can't remember what I told you on Monday, 6-4 quiz. I've got that graded, and I believe I've put that on Blackboard. Kind of one of the difficulties in this methodology of teaching is giving you the quiz back, or somehow how do I convey to you your results on the quiz other than a numerical grade. You don't know what you did well on, you don't know what maybe you didn't do so well on, what you grasped, what you didn't grasp. And that's one of the kinks of, hopefully we don't have to go back to the system, but I don't like that we can't give you can't kind of see what you mastered and what you didn't master. You may have to go back and regroup and refocus on. But we'll hopefully 2 more weeks of this, and then come August we'll be on bigger and better things in the more traditional way of education. So I don't think I've got any other announcements. Anybody have AP exams next week that I'll miss you on? Any AP guys in here? If you do, just send me, if you realize you got an AP exam, because my understanding is if you have an AP exam that day, you don't have to go to class that day. You still can, but you're not required to. So if that is an issue for you, just say, hey, I'm missing class today because I'm taking AP history exam or whatever it is. All right? Okay, so here's the plan of attack for today. We started section 6.5 on Monday on operations with radical expressions, which is basically simplifying things under the radical. And we've done off and on lots of this over the last 4, 5, 6 weeks, but the complexity definitely has ramped up with this particular section. And I went through, sharing my screen, I went through problem set 1 and went through the examples and all the kind of background information and did 1, 3, and 5. Then you were supposed to do 2, 4, and 6. Let me see if I can pull up the answer key and share the screen with you. All right, and there is, my writing sometimes is suspect at best, and sometimes when I put this as a PDF and scan it in, it doesn't come across real clear. But here's the answer for number 2. You already 1, 3, and 5 you should have, which is 2a squared b to the 5th, and then that's 2a under the radical, not 20 minutes, 2a. So take a look at what you got. Hope you invested 20 minutes or so doing these 3 problems. It didn't even take you that long. And if you're not getting that, or like, where the heck did that come from? Ask me that question, and I'll put the problem apart, and we'll kind of go back through and walk back through the steps. So that's number 2. You can see number 1 off to the left, which we did in class, so no surprise there. Okay. See if I can get both of these on here. Maybe I can. Yeah, I think I can. Give me a second. All right. Let me get this out of the way. So here's number 4. Remember I talked about on Monday. Sometimes if you, and this is those rules and properties at the top of the page, sometimes if you rewrite this thing as 2 separate radicals, you see things that you don't see when it's written as it was originally given to you. Because the square root of 36 is 6, check, that's easy enough. 125, I know that's divisible by 5, so if you didn't know 25 divided into that, you could start factoring out 5. So I would get 5, and I think I did this for the other day, and then I get 5 times 25, right? And then the bells and buzzers start going off, because I know 25 is a perfect square. So that comes out from under the radical as 5, and then the 5 stays under the radical. And then we talked about the complex conjugates, which you were exposed to 5 weeks ago. I don't know. where we can't have radicals in the denominator, which is the lower half of the fraction. So how do we fix that? We multiply it by itself under the radical, which, remember we talked about, if I multiply the square root of 2 times the square root of 2, the answer is the square root of 4, or 2 squared under the radical, or more simply, it equals 2. So this 5, the radical 5, or 5 radical 5 times radical 5, this times this comes out, becomes the square root of 25, or comes out from under the radical is 5, and the 5 times 5, or 5 times 5 gives you that 25 there. And then the 6 times radical 5 is just as.
Mr. Gaffney,
Yes, sir.
was there a Dropbox, or because I couldn't find one on Black?
No, because there was only 3 problems. So
Okay, so
I
you just
see it. There will be with what we're going to do today, but not last. And having 2 drop boxes a week is a maintenance nightmare, to put it politely and diplomatically. So I'm probably just going to do 1 graded assignment each of these next couple of weeks.
got it.
Okay, now number 6 was a bit of a bear. All right, so I went after the 40 first because that's just easier, and I just started factoring 2's out of there. Now, pay attention, we're not doing square roots, we're doing cube roots in this one. So if I factor 2 out of 4, I get 2 times 20. And then if I factor 2 out of 10, I get 2 times 5. So there we go. There's 2 to the 3rd power right there. So that can come out from under the radical as 2. Check. And we got the 5 that stays under the radical. So that's how we did the first part. And then I think I gave you some hints and clues on Monday. Let's change that p to the 5th to p to the 3rd times p squared, right? Because when we're multiplying identical bases with exponents, we add the exponents. So 3 plus 2 is 5, right? So the p to the 3rd comes out from under the radical. I forgot to put 3 here. Comes out from under the radical as, I see I made a mistake here. Comes out from under the radical as p. I'm going to go back and correct a mistake I see, but I'll address that in a minute. The q cubed, that's hard to say. So that's just q times q just comes out from another radical as q. I didn't realize this till right now, just kind of walking you back through this. This was a little bit of a trick problem, all right? We cannot have the complex conjugates, we cannot have a radical in the denominator. So I'm going to fix something here. You may have made the same mistake I did, in that so by forgetting we're doing cube roots, not square roots. So we do not multiply by radical 5. We multiply by 25 and 25. Why do we do that? Because I've got to have, because I'm doing cube roots, so 5 times 25 is 75, which is 5 cubed, right? So we actually had to multiply by radical 25, not radical 5, which then would give us, so this comes out from the radical is 5, and that gives us, drawing a bone far, 2 times, what does that give us? Give me 1 second here. Oh, so now it comes out, yeah, it's still, actually that is a right answer, except this actually, it's 25p squared on the top. So it changes that part of it. Does that make sense? Excellent. And I didn't even think of that till I was starting to explain it to you. I didn't think of it when I was prepping the sheet for today. Questions or comments? Any discussion? Anything I need to go back and retrace? I need to talk about 6 more since I kind of led you a little bit astray initially. Again, this should have been 25. Because why? Because it's a cube root, and I got to get rid of that radical. If I go 5 times 5, that's 25. Well, there is no even cube root of 25, but there is the cube root of 75 is 5. So by not carrying those 3's there, I ignored it, overlooked it, and did it incorrectly. Any questions or confusion before we kind of venture into some additional work on this? Did we get these answers? I only had 3 of them. All right, I'm gonna have to, let me, do something here. Where's my pen? This thing's not very user friendly. All right, there we go. So I'm gonna have to unshare my screen because I can't flip documents around. All right, so here we go. I've already loaded Blackbot. If you have the luxury and niceness of an office where you can print this out, I loaded it just a little before class. If not, you can handwrite the problems and print it later, or just handwrite them and put them on the safe paper. Okay, are we ready? My stuff organized here. All right. Now we're still going to be simplifying radicals, but it's a little bit different slant from what we did on Monday. All right. Let me go over a couple things here. Let me scroll up. So we're always simplifying. Typically, you're not solving. You're just kind of simplifying. And by simplifying, we want to get as many perfect squares or cube roots or fourth roots, whatever it is, out front of the radical as we can. And our final answer can't have a radical in the exponent. All right, it's in the denominator. All right, so let's just I'll just kind of read this collectively with you because I want to pick a couple of key points out. It says operations with radicals. Operations with radicals, when you add expressions containing radicals, this is the key point. And if you can remember when you print this thing out, you can only add like terms or like radical expressions. All right, what is a like radical expression? Let me see if I can find one here. All right. Like radical expressions. Let me see if, all right. These are like radical expressions, right? Which is the same radical with the same root with the same radicand. Remember, the radicand is that value underneath the radical symbol. Those are like radical expressions because they're both some number and then the square root of 6. I mean, this could have been 7 and 8 or 5 and 2, but they both have the same number under the radical. So those are like radical expressions, and you can add or subtract those together. All right, that's what they're referring to here. Let's see here. And it says 2 radical expressions are called like radical expressions if both the indices and the radicands are alike, meaning the indice is whatever this root is down here. All right, both square roots are both cube roots, and the radicand, the value under the radical, are both identical. That's what that is. All that stuff is saying. Questions on that? All right, so this is where it starts getting a little, the water starts getting a little muddy. It says, all right, now to multiply radicals, all right, this was talking about adding and subtracting. Here we're multiplying. Use the product and quotient property for products of the form A radical B plus C radical D times E radical F plus G radical H. And we're going to FOIL. And we know how to FOIL now, right? Except now we've just got the additional complexity of, we've got some radicals sprinkled in there, right? And we have to rationalize denominators, which means no denominators with a radical there, using conjugates. We just talked about that just a few minutes ago with a couple of those problems from Monday's exercise. Okay, and this says what when we were talking about complex conjugates back about 8 weeks ago. The numbers of the form A radical B plus C radical D and A radical B minus C radical D, where A, B, and C and D are rational numbers, are called conjugates. All right, and if remember, you don't have to memorize this, but with this negative CD and this positive CD, remember that? Remember we talked about the FOIL? That means the O and the I are going to cancel each other out. The O and the I of FOIL are going to cancel each other out because it's the same value but opposite sides. If you kind of just remember that, that's what's kind of helping you move the ball or helping you simplify these problems. And here we're just calling them conjugates. Back 6-8 weeks ago, we were calling them complex conjugates. And it says the product of conjugates is always a rational number. And again, that's kind of like lawyer talk. What the heck does that mean? So what's that mean? So if I multiply radical 5 times radical 5, it's just, or the square root of 5 times the square root of 5, however you want to, either way you want to phrase it, same thing, right? You get the square root of 25, or you get the answer 5. That's an example of what they're talking about. Fair enough? Questions before I move on? All right. Okay, I'm trying to debate whether to use these examples or not, because they kind of, I think I can show you a simpler way than what they're doing. I'm going to go ahead and talk about it. All right, so let's look at example 1. We got 2 radical 50 plus 4 radical 500 minus 6 radical 1 1/4, 125. Okay, so I can't add any of those because they are not, quote unquote, like radical expressions, or for lack of a better term, like terms, right? Because they have to have the same indice, which means the same root, and the same value under the radical, also known as the radicand. However, I can simplify each one of those, probably to some degree or another, and possibly get some like radical expressions. And that's what they did here. Actually, I'm reluctant to use this because I think I can show you a clearer way. Yeah, I think I'm not going to use that. Let's just do it. Yeah. If you print this out, you can use this as a reference, because this is a little bit confusing the way they presented it. So let me try to do my way, and hopefully it's a little more clear than the examples. All right, so let's maybe we'll come back. Maybe I'll come back to the examples. Okay. So if you want to take a minute and write problem 1 down, I'll give you 30 seconds, and then we're going to talk about how we're going to solve these. And as you're writing down, the ultimate goal is I want to get like terms, or as they say here, like radical expressions, and hopefully by simplifying that is going to occur. So here we go. All right, this guy here, I can't simplify any more than what it already is. All right, this guy here, I see 50, so I know 25 goes into 50, so that's 2 times 25, right? I'm going to do it up above here. All right, 50 is the same as 2 times 25, right? Everybody agree? Everybody can see that, right? And we love 25. Why? Because it's a perfect square. So I'm going to rewrite the problem. I can't do anything with that first radical term, so I'm just going to carry it on as is. And now I can rewrite that 50, or simplify that 50, as the 25 will come out from underneath the radical as 5, right? And it'll leave under the radical a 2, which we love. So now I got 2 like radical expressions, or like terms. Well, let's keep going. This guy here, 8. All right, so I know 8 is 4 times 2, right? And I love 4 because 4 is a perfect square, right? So the 4 can come out from underneath the radical as a 2, right? I mean, let's just to keep things straight. So that's the same as 4 times 2, right? So the 4 comes out from under the radical as a 2, and what's the relationship between these two? It's almost like a coefficient of verbal. It's multiplication. So 2 times that -4 is a -8. So now I've got -8 with 2 still under the radical. All right. Are we good so far? Anybody lost in the sauce? All right. So now actually it's the best case scenario. I've got 3 like terms, or 3 like radical expressions. So 3 radical 2 plus 5 radical 2 is 8 radical 2, right? And now I'm subtracting 8 radical 2. So my final answer is this, right? Everybody see that? Does that make sense? So the moral of the story is we are going to simplify the radical expressions we're given in the hopes of achieving some like radical expressions that we can then kind of combine and consolidate and do whatever the math is it's telling us to do. Make sense? All right. Any questions before I move on? So really, to me, that's a little bit easier than what we did on some of those problems from Monday. Okay. Right. Copy problem number 2 down. I'm gonna give you a couple things to think about, and then I want to give you some time to work it, and then let's come back together and do the answer. Now, if I see 20, I see 2 times 10, or 2 times 2 times 5, or 4 times 5. So I'm going to just give you some things to think about to kind of start you down the yellow brick road, and I'm going to let you finish it. So use that to your advantage. I see 125. We just messed with 125 in a previous problem. I know 125 is 25 times 5. Ooh, I got 2 problems both with 5. I see 45 and I see 9 times 5. I see a perfect square and I see a 5 there. All right, so you go from there. I'm going to give you 2 minutes, and then you come up with the solution with the start I've given you. All right. If you want to ask questions while you're working, that's fine. Anybody have any questions while you're chipping away at it? I mean, I think these are kind of interesting because it's kind of like a puzzle that you're trying to solve. It's kind of like a challenge. All right, you ready to go? We good? Everybody awake? All right, so the 4 would come out front of the radical as a 2, right? Because the square root of 4 is 2. And I got 2 radical 5 for that 20. I just simplified the 20 under the radical. Similarly, I'm going to take that 25. I love 25 because that's a perfect square. That's going to come out under the radical as 5. And I still got 5 under the radical. That is perfect because now I've got at least 2 like expressions. And then we love 9 and 5 because 9 is a perfect square. Bring that out from the radicals 3, and I still got 5 underneath. Did everybody get that far? Hopefully. Are they speechless? No one's listening. All right. So we got 2 plus 5 is 7. 7 minus 3 is 4. So my final answer is 4, and hopefully your final answer. So we have the same thing. We both got it right. That's always a good thing. Is 4 radical 5.
How did you get that 4 radical 5?
All right. So you can almost, we're almost treating, if you look up at the top of that, well, you don't have a sheet printed out, right? Like radical expressions. Let me change things. Like radical expressions, I'm going to go over the other problem, is the same value under the radical, known as the radicand, and the same indice, which is the root, right? Like radical that's a like radical expression, that's a like radical expression. And you can think of the 3, the 5, and the 8 almost like as a variable, and the like radical expressions as a coefficient. So if this was 2x plus 5, if the square root of 5 is x, you could say this is 2x plus 5x minus 3x. Well, 2 plus 5 is 7, right? And a 7 minus 3 is 4. Does that make sense? I can add those all together because they're like radical expressions. Same radicand, which in problem number 2 is 5, and problem number 1 is 2, and same indices, meaning what's the root on all of those 3 in number 2 and all those 3 in number 1 are all square roots. So they are like, they're the same as like terms. So I can add and subtract those things together. It's like having the same variable. Other questions? Like I said, it's kind of like a puzzle. I think it's kind of easier than stuff we did on Monday. All right, let's do something. All right, so, oops, too far. Okay. All right, let's look at number 3. Write that on your loose leaf paper. Write that problem down. I'll give you a second, and again, I'm going to I'm not going to solve it for you initially. I'm going to kind of point you in the right direction. You probably already see some things here that you can simplify, right? So write it down, and I'll talk you through it. I'm going to give you some options. Okay, how about this? All right, when I see 300, I see 3 times 100. Remember, I think it was in Algebra 1, we spent a couple sections where we rewrote values in different terms that are equivalent to the same thing. So I like that because the 100 is a perfect square, it could come out from the radicals of 10. I see 27, and so to me, I see that's the same as 3 times 9, right? I see 75, and I see 25 times 3. You can see we're using some of the same values over and over. So you kind of start seeing a pattern or routine developing, right? But let's say you don't see that, right? You just don't see it. All right. So remember I talked about either Monday or last Wednesday. If I got an odd number, let's look at 27. All right, I'm going to start factoring out values. Well, it's an odd number, so I can't use 2, but I know I can use 3. So if I divide 27 by 3, that's the same as 3 times 9. If I see 9, I know that's 3 times 3, right? So, and there's a number times itself, which is a perfect square that it could come out from if the radical is 3. Just like on 75, all right? If you didn't see 25 in here, all right, remember I said if a value ends in 5 or 0, I could start factoring out 5s or 10s, right? So let's just say I factor out a 5. So if I factor out or divide 75 by 5, I get 5 times 25, right? All right? No. That's 1, 5? 5 times 15, is that right? Yeah, 5 times 15. Where did I get 25? All right. And I see 15. So I got 15. So I still got a value in 5. So I can 15. I can factor out another 5. So I got 5 times 3. Right. Now I've got 2 5s. Just like the 300. If I didn't see that 100 in there, I could start factoring out 10s. So now I've got 10 times 30. Right. 10 times 30, and now for 30, I can factor out another 10. I got 10 times 3. So if you don't see these perfect squares in kind of inside or within a number, you can just start factoring out and get there. It involves a couple more steps. And as you do more of these, you'll start getting those patterns and rhythms of numbers like the 27s and the 75s and the 100 1/4s and the 111s and the 169s. That we keep using over and over and over. Does that make sense? Okay, so with that being said, I'm going to give you a couple minutes, and I want you to work on this one for 2 minutes and see where it takes you. Okay, and I'm going to come back in and either have one of you all walk me through it, or I'll do it. Okay. So the 100 comes out from the radical as a 10, right? And it leaves 3 under the radical. The 9 comes, and we subtract, 9 comes out from a radical as a 3, and we still have 3 under the radical. 25 comes out from the radical as a 5, and we still have 3 under the radical. Perfect. I got 3 like terms, right? I got 10 minus 3 is 7, minus 5 is 2. So my answer is 2 radical 3. Bada bing, bada boom. All right, questions on that guy? All right, on number 4, just make a note. I'm just going to give you a clue, a beginning clue, and you go from there. All right. Number 5. Number 5, what are we doing in number 5? Number 5 and 6. Number 5 and 6 are the same, done the same way. Okay. I'm going to maybe start you on 5 and you're going to do 6. Number 7 and number 8 are foils. And we've done foiling, so hopefully I think you're probably pretty decent at foiling. All right, so let's look at, let me walk you through number 5, because it's now, what property are we, excuse me, are we applying on number 5?
Distributive.
Distributive. All right, so let's just do it. Don't get hung up like, oh, this is multiple radicals, distributive. What do I do? Let's just kind of do what's put in front of you. All right, play the hand you've been dealt. All right, so what's 2 times 4? It is 8, right? Now we're doing cube roots, so I don't want to forget that, so I don't mess it up from before, right? And then we got 2 times 12, right? What's that equal? That's 24, right? And we're still doing cube roots. All right, so let's simplify things. Can I do anything with that cube root of 8? Oh, certainly. The cube root of 8 is what? It is 2. 2 times 2 times 2 is 8, right? So I just took care of this guy. He's done. Now, I got 24 into the radical. Now, I could start factoring out 2's again. Or if you see that 24 is the same as what? 8 times 3, right? 8 times 3 is 24. Ooh, there's that 8. I love 8 because 8 is 2 cubed. So that 8 comes out as 2, and I still have 3 under the radical. So, and this is my final answer. I can't go any farther because those aren't like radical expressions or like terms. Put it in verbiage we already knew. All right, so you're going to do 4. You're going to do 6. Actually, you're probably going to do all that, evens. Any questions before I move on? Let's see, we're in good shape time-wise. Any questions before I move on? Let's see here. Give me a second. I'm going to scroll page up a little bit. Let's see what we got left. Let's see what we did. So you're going to do 2. You're going to do 4. You're going to do 6. When I do 7, and you're going to do all the evens. Okay. Let's see here. 7, 8, and 9 are all foil. So let's do 7. All right. So it's like, oh man, I got radicals. What do I do? I got radicals with values outside of the radicals. Well, let's just do what it says to do. So let's just do it. F, 2 times 4, that's 8. All right, I got the F done. I got to do the O. 2 times radical 7. So what's that equal? 2 radical 7. Rocket science. All right. That's FO. Now I got to do the INL. I got 3 radical 7 times 4. So 3 times 4 is 12, right? And I still got the radical. Wait, why did I write 3? Let me have a brain. It's 2 radical 7, right? 2 radical 7. Let me fix this. I got a mess. Okay. Did I say 3? Where'd that come from? I think I'm getting ahead of myself. It's 2 radical 7. All right. So let me back up. So now I got 3 radical 7 times 4. So 3 times 4 is 12. So now I got 12 radical 7, right? Now, that's my O. And here comes my L. So now I've got, since my pen doesn't write very well because I'm doing it on a scratch pad here. So I've got 3 radical 7 times radical 7, right? So radical 7 times radical 7 is 49, which the square root of 49 is 7. Or as we've said before, anything under the radical times itself on a square root basis comes out as itself. So this equals 21. Does everybody see where I got the 21 without writing it all down? The 21 comes from the 3 radical 7 times the radical 7, right? Does anybody see where that comes from? Do I need to go into any more detail? Okay, so now I've still got 2 like radical expressions I can combine. And so if I combine 2 radical 7 plus 12 radical 7, that is 14 radical 7, right? Where am I? Yeah, 14 radical 7. And I got 8 and 21, which are like terms. I can add those. So it's, oops, I keep wanting to get ahead of myself. It's 8 plus 21 is 29. So it's 29 plus 14 radical 7, or 14 radical 7 plus 29. Questions? Very good. Okay, so you're going to do 8 because it's handled the same mechanics and methodologies for number 8. Okay. Let me scroll up here. Give me a second. You're going to do 9. 8 and 9 are just like 7. So you're going to do 8 and 9. Now number 10. Let me, 10's a horse of a different color, as they would say in Wizard of Oz. All right. Let's see. I'm looking here. Before we do anything, let's see if we can simplify. I know I can't simplify anything in the denominator, but I can in the numerator. Tell me something about 48. Anybody? It's 16 times 3, right? So why can't I bring this 16 out front of the radical as a 4? And so now I've got 4 times 5 is 20. I got 20 radical 3. Now, tell me something about 75. All right, something about 75. Again, that's a number we've dealt with today and on Monday, I think. That's, or 75. That's 25 times 3. So that can be rewritten or simplified as 5 radical 3, right? So we're making progress. So I've got 2 like terms I can combine on the numerator, 2 like radical expressions. I've got 25 radical 3 as a numerator over 5 radical 3. All right, remember the conjugates terminology on the front page, which says no no radicals in the denominator. So I'm going to set you up and I'm going to let you finish it from here. So what are we going to do? We're going to multiply it times itself. When I do the numerator, I got to do the denominator. Like when I do the left side expression, I got to do the right side expression. So you do that and finish that one, okay? So I'm gonna let you finish that. How are we doing on time? All right, let me see what I want to do here. I'm gonna get you started on. I'm gonna give you the setup for 11. Here's your complex conjugates or your conjugates again. So now I'm gonna multiply both. Sorry about that. I'm gonna multiply this side by. Oops. Picture. This. I'm going to multiply both sides by 2 plus, where's my pen? I think my pen's wearing out. I'm going to multiply the numerator by 2 plus radical 2. And I'm going to multiply the denominator. When I do the numerator, I got to do the denominator by 2 radical 2. What's that going to do for me? Remember when the O and I have opposite signs like they would in this case, they're going to zero out or cancel out, all right? So you're going to do like dual foiling. You're going to foil the numerator, foil the denominator. Some of these radicals are going to disappear and go away because anytime you remember,
Mr. Gaffney.
multiply radical 2 times radical 2, or anything under the radical times itself, is going to equal itself. Go ahead with the question.
I said I gotta go. My mom needs this laptop for work.
Okay.
It's only 5 minutes. Is there anything you need, last announcements before I go?
Just finish all the evens, number, all the, you're going to do 4, 6, 8, and then 9 through 12. 4, 6, 8, 9 through 12.
All right.
Okay, 4, 6, 8, 9 through 12. All right, and then how are we doing? We got time. All right, so on this one, you already know the drill, right? I'll set you up. We're going to multiply times 1 minus 2 radical 3. And this. Okay, so we're going to do a lot of foiling. We're going to do a lot of combining the like terms. We're going to do a lot of conjugates. All right, so I think that's the setup of everything. So let me make a note. And it's already loaded on Blackboard. So let's see. We did 1, we did 2, we did 3. I set you up on 4. I did 5. You're going to do 6, 7, 8. Actually, you're going to finish 10, although I did a big part of it. So 6 through 12. Number 4 and then 6 through 12. Okay, 4 and 6 through 12. We've done all the rest. All right, we got a couple minutes left, and I know I kind of packed as much in as I could. If you run into a snag or a problem, either go to Khan Academy or Patrick JMT, and then just type in operations with radical expressions. There's examples in both of those websites that you can use to hear a different person's explanation of how to solve these and to refresh your memory. Okay? Questions? Anything I can clear up? Do we feel like we got a kind of decent handle on it?
Yeah. Yeah.
Anything I, what's for lunch today, Mr. Lingle?
Women's jacket.
Chicken.
Chicken, all right. Chef's been feeding us well. Anything I can clear up? Mr. Bubblehouse has lost his razor. Last call for questions. If you run into a snag and you want some help, office hours 2 to 2:30 today and tomorrow, 9 a.m. to 10 a.m. on Friday. So if you can do these and drop these in Dropbox, ideally by tomorrow evening so I can take them, print them out, because sometimes I don't come into school on Fridays since we don't have classes. Then I can score them and then we can talk about them on Monday. Questions on anything?
Do you want this work turned in today?
If you could do it by tomorrow afternoon, I can print them out before I go home tomorrow evening.
Okay.
That would be very, very helpful. Friday at the latest. I'll score those just on the computer because I can't print all this stuff out at home. All right. Any last minute questions before we call it a day?
Yes, sir.
All right. If you think of something in about 10 minutes, I'll be in office hours today and tomorrow, 9 a.m. to 10 a.m. Friday. All right. Everybody have a good weekend. Stay safe. Hopefully our governor will relinquish his death grip on the state and on all of us, and we can get out and start being a little more normal. Otherwise, I will see you on Monday if I don't see you in the office hours. Okay?
Yes, sir.
All right. Be safe.
Yes, sir.
See you, Mr. Gaffney.
Okay. We'll see you.